Today I'm going to demonstrate the first ever SORBA.ai no-code machine learning integration add-on for Ignition SCADA. I'm going to show you how you can supercharge your Ignition SCADA. Combined with our SORBA.ai platform that runs entirely on the edge, you'll be able to create machine learning algorithms for clustering, anomaly detection, classification, regression, and inferencing models. You can create digital twins, replica and simulation models. You can also build forecasting models and our very powerful proprietary advanced process control and optimization. Once you install the SORBA software on the edge, either on the same computer as the Ignition SCADA or on a separate computer, you can then install the SORBA integration module. Very easy to configure, and then set up the MQTT settings specifically for the SORBA module. And that's it. Once you have these two configurations set up, you're ready to go. Now you're ready to create machine learning models in the Ignition Designer. Let's go to the UDT Definitions tab, and you will import our predefined SORBA UDTs that allow you to create classification models, clustering models, digital twin, forecasting, optimization, and regression. So once you import those in, which I have here, you can then assign your inputs to your UDTs, and this can be any inputs. You'll notice that the outputs don't have any tags. These will automatically get created once you create an instance and train a model. The SORBA.ai API will create all of the output tags that correspond to that specific model. Once you have the UDTs imported, let's now go to the instances, and let's create an instance of a motor classification. We will give it a name. We'll call it Pump Anomaly 1. You will see then you now have the same structure as your UDT configuration, your inputs and your outputs. Once you have that configured, the next step is to configure the training set. Very simple. You set the start date of the training data. I'll start with a few days of data back in February 27, and my end date will be a couple of days later. Once you have defined the start date and the end date, the last step in order to start training the model is to enable the initialize training boolean. Once this is initialized, the SORBA integration module will send an API call to the SORBA platform that will query the Ignition historian with that start and end date, send that data to the SORBA.ai machine learning trainer, import it as a data set, and start training a clustering model for these specific inputs. So let's go ahead and enable the initialized training. Once it's enabled, the output message will change from waiting for training to requesting historical data from the pump anomaly with the following start and end date. Once that data has been imported into SORBA, you will see that the SORBA now is training in process the pump anomaly 1. After SORBA has finished training the model, it will then report back a message that the model is already trained. This is now ready for you to display the output of that model and the prediction. So you will see now that the outputs have been created by the SORBA API, and you have an assortment of different tags that automatically get generated. The anomaly detection analog, the Boolean, the high and low threshold, and the real important one for clustering is the anomaly score percent. This is the tag that will indicate whether an anomaly has been detected. A threshold of 80% will indicate an anomaly. Anything above an 80% is considered abnormal or anomaly. Anything below 80% will be normal, or close to 80 would be a warning. So now you can use this tag to display it on the screen to generate an alarm or a warning, or send it to an operator. This is very handy for integration into Ignition because it allows you flexibility on how you want to take action. In addition to anomaly score, you have other statuses like the data drift, prediction drift. Every single input is also analyzed for data drift. Here you have current, frequency, power, you have speed, temperature, AC voltage, and DC bus voltage. So every single input, we analyze data drift, we analyze the data or the drift score. We also analyze the outlier detection. If the current is outside of the statistical outlier, it will also provide an indication that it is either deviating or it may have a drift that's associated with a calibration problem or some indication that it's not within the statistical limits. In addition to, we also provide a tag ranking that is an indication of how it contributes or impacts the anomaly. And we provide the p-value. So this is a very powerful analysis. Not only do you get the anomaly score, but you also get the root cause analysis of every single input. So if I'm having a current issue, the current tag ranking will start to elevate as the highest level compared to the other tag ranking inputs. So now let's create a display and trend the anomaly score. I'm going to create a screen. We'll call it Pump 1 or Pump 2 since it already exists. And I'm going to insert a easy chart to trend the anomaly score. Since this tag is already historized, I'm going to drag this in and you will see that it's starting to trend. I'm going to change the status from historical to real time so it will update the anomaly score. You can also display the tag ranking that will show you which input is the possible root cause of an anomaly. Since we don't have an anomaly, it really doesn't provide value, or it could lead into a problem once you start seeing certain conditions elevated. So I'm going to drag in the current, I'm going to drag in the frequency and the power just to show you an example. So the power seems to be elevated a little bit, which indicates the impact or contribution to the anomaly detection algorithm. So these are all analysis that you will get automatically by creating a SORBA machine learning algorithm clustering into the Ignition platform without any interaction with SORBA. Now the user can work within the Ignition environment and have the powerful capability of machine learning of the SORBA platform without ever going into SORBA software. This is how you supercharge your Ignition SCADA.